Now we will discuss the unification of physical theories. So this is the unification of physical theories. We know the fact that electricity and magnetism, they were separate subjects. Electricity and magnetism, as we study in the early classes, so they were considered as a separate subjects. Like the electricity was dealing with the static charge, like charge on a glass rod or the kite sphere, pith balls, the batteries, even currents and electrolysis and lightning, they were under the regime of electricity. Similarly, the magnetism is a separate subject, was dealing with the permanent magnets and like the compass needle, etc. It was Oersted who for the first time in 1820 observed that when an electric current flows close to a compass needle, that it can deflect the compass needle, and this was the first observation that the electric current has something to do with the magnetic field. And this was then very soon formulated by Ampere, that the one that we know is Ampere's law. It was formulated that basically the moving current, or the current means the moving charge, or the current generates a varying magnetic field, and it was formulated as del cross B is equal mu naught J, where J is the current density, the electric current density, the current per unit cross-sectional area. So when current flows, then it will cause a curling magnetic field. The cross product here means the rotation is involved. This is the del operator. So combinedly, these two we can call as curl, means the del and the cross. This is the curling of the magnetic field. So when current flows like this in a wire, then magnetic field is going around it, and vice versa. And then after 11 years, when Faraday's made another observation, it was 11 years after this that he observed that if you move a magnet close to a wire, then it can cause a deflection of the galvanometer, or it can cause a current flow inside the wire. And this was formulated as that del cross E is equal minus curly B over curly T. Like when magnetic field changes with time, then it will cause a curling electric field. So it is the variation of magnetic field is causing the generation of electric field, and it was the observation of Faraday's. And then soon after this, there was a complete theory of the electrodynamics, or it was just like, look here, that here we are having current per unit area, means charge per unit time per unit area, and it is having a connection with the magnetic field. And here it is the variation of the magnetic field which is having a connection with the electric field. So it means that the electric and magnetic field are not separate from each other, but they are kind of a combined thing, intertwined thing. uh, they are not independent of each other, and they are means variation of one in time is causing the generation of the other in space, because this is the space derivative del. So this is the space curly E, del cross E. This is space variation of electric field, and this is the time variation of magnetic field. And soon after this, the two legends, the Maxwell and the Lorentz, formulated Maxwell and Lorentz. They unified this uh, situation of electric and magnetic field, like they are no more independent of each other, they are the same thing, their source is the same. And the set of Maxwell equations, or the Lorentz formulation, they combined these things into one theory of electromagnetism. And even then, Maxwell went further by combining all the equations, like the very first one, which is the Gauss's law. Divergence of electric field is equal to rho over epsilon naught, while the magnetic field does not diverge at all. And the curling electric field is generated by the timely varied magnetic field. And similarly, the curl of the magnetic field is equal to mu naught J. The story was incomplete until the Ampere's law was corrected by Maxwell with an additional term which we will discuss later on, the mu naught epsilon naught and curly E over curly T. So this is just now, if I just ignore this term and look at this one, then this is, here is del cross E, so curly B by curly T. Here del cross B and curly E by curly T. So if you vary magnetic field in space, you are having in time, you are having electric field in space. If you vary electric field in time, you are having magnetic field in space. So it is all the situation of the two which are intertwined with each other. They are not separate from each other. Here, the name of electromagnetism means the electricity and magnetism were unified into the term of electromagnetism after Faraday's equation, that the electricity and magnetism, they are now sharing the same source, and now they are not a different subject like electricity and magnetism, but it is electromagnetism. And when Ampere corrected this thing, then he came to the conclusion that this is not even electromagnetism, but this is electromagnetism. electrodynamics. Charge and motion, because when we are having a static charge, we are having the concept of electric field only and no concept of magnetic field. And when this charge is in motion, then we are having the concept of electric as well as magnetic field, because charge in motion we call current. When we vary the magnetic field in time, then it causes the electric field in space, and similarly varying the electric field in time generates the magnetic field in space. So this thing was termed as charge in motion. It is all the game which is played by the charge, like this charge static and this charge when in motion. So this unification in the form of electromagnetism was further moved by Maxwell to electrodynamics, that this is the charge in motion, and basically magnetic field is nothing else but a varying electric field. And we can see from the Lorentz formulation, the Lorentz equation is that the force is equal to QE plus QV cross B, the electric and magnetic component of the force, which we call the Lorentz force. This is a force and this is a force. If both the forces are equal, then I can write that QE is equal to QV cross B, and QQ are cancelling here, so I can write in a scalar form, considering the particle moving perpendicular to the magnetic field, then electric field is equal to VB. So the only difference between the electric field and the magnetic field is the speed, is the motion. So electric field is just equal to V times B, means this is the velocity, means the motion of this charge which is involved here, which is causing things to be seen as electric or magnetic. And when Maxwell did this correction, then he proved that this V, which is equal to 1 over mu naught epsilon naught, which exactly came out to be the speed of light. The variation, which is 2.99792548 and 10 power 8 meter per second. Like the variation of one into the other. When electric field vary, it generates magnetic field. When magnetic field vary, it generates electric field. So how quickly is that generation? That generation is at a speed of light. That is not instant, but it is at some speed. This occurrence at some speed, and that speed is the speed of light. And here, like we are having electric and magnetic components, they are varying into each other. So their propagation, their variation is their propagation, and their propagation occurs at the speed of light. So all the electromagnetic spectrum, which was then in 1900, which came under the discussion. So it is a big range. It's a big range of electromagnetic waves, and a tiny region of this is the visible range. So it starts from the micro radio waves to gamma rays through infrared, microwaves and infrared, and then the visible, and then the ultraviolet X-rays, and then gamma rays. So another thing which came into this one is the optics. means like we are calling light, light and the phenomena which are associated with light, for example the refraction, reflection, transmission, the diffraction, interference, all those phenomena, they were explained with the help of the set of Maxwell equations. So optics, these three things combined, the electricity, the magnetism and the optics combined into one thing, which was the electrodynamics. So all of them came under one thing, and this was one of the biggest unification in the history, and especially in the history of electrodynamics or in the history of physics. So we can see here that one thing which is evident from the Maxwell equation, from which Einstein started, the concept of space and time. Look here, variation in space and generation in time, or generation variation in time and generation in space. So two different things. The things which seems to us in space is electric field is the magnetic field in time, are the things which seems is magnetic field in space, then they seems to be electric field in the frame of time. So the space and time are involved here, and Einstein started from here, and in 1905 he formulated his special theory of relativity, and that relativity was based on the Maxwell equations, that basically electric and magnetic field are not two separate things. It is just the game of the reference frame, because in one reference frame it may seems is electric field, while in the other frame it will be a magnetic field. So these two are actually the same thing, but the only difference is of the frame in which you are. It is your the things that does matter is your observation frame in which you are observing the things. I can give you a very simple example, and that example is that, for example, I'm having a briefcase which is full of charges, and I'm going in my car. And now inside the car, the briefcase is with me, and so if I'm having a meter which detects the charges, so I'm only detecting the electric field inside my car. But to another observer who is stationary outside, I'm moving with respect to that observer. Now to that observer, I'm not electric field but magnetic field, because I am a moving charge, and moving charge is called current. So current will have its magnetic field. So to that stationary observer, I'm magnetic field. So it's only the difference of the frame, and the things means the source is only one thing, which is charge. So Einstein published his PhD paper on the moving of electrodynamic objects, and from here he just formulated the special theory of relativity. And I have explained this thing in the introduction to the special theory of relativity. You can find the link above to this lecture, so you may have for further details there. And then, in addition to this thing, Einstein was further dreaming of the unified theory, the unified field theory, because if we look at back to the history, he was successful in just formulating this thing, the special theory of relativity, based on space and time and on the Maxwell equations. In this one, it is for the inertial frame of reference, means the frame of reference which we consider stationary or moving with a constant velocity. So in that situation, we consider the acceleration equal to zero. And when we consider the real life, we don't have any such frame which is having acceleration equal to zero. So for the acceleration non-zero frame, mean the non-inertial frame, how this theory will convert means, that is the acceleration non-equal to zero, we have gravity. So if you include gravity in this thing, then he formulated, means he took around 10 more years to incorporate the gravity in it, to incorporate the non-inertial frames in it, and formulate the general theory of relativity. And he was successful in this one, and this is one of the theory which ruled the world for more than 100 years, and still the things are going on. But Einstein even dreamed further of the unification of the field theories, like the unification of these two has already been done. This one is closer to it. So that these three, if you combine with a big difference here in the magnitude of the strength of this, the gravitational force, so to combine this in order to have a unified field theory, means the theory of everything. And that was the dream of Einstein, for which he worked for almost 10 years, or the last 10 years of his life, but he wasn't successful. Although Einstein was not successful in the unified field theory, however, later on in 1960s, there was a success on combining these two, the electromagnetic force and the weak force, into electro-weak force by Glashow, Weinberg, and Salam. So the and later on, a theory of the super string theory, which is in short called the string theory, which unifies all the four in it and can be termed is the theory of everything. Um, but yet a lot of work is to be carried out in this one, because things are not like well established, just like it was established in the electroweak force or in the unification of electrodynamics. So this research is going on, and it is called is the theory of everything. In this course, we will not discuss such an advanced things like superstring theory, but we will discuss the electrodynamics, means the charge in motion. So the source of our field is charge, and we will discuss charge onward, that what is charge, how the what's the magnitude of this charge, what's the minimum value of this charge, what is meant by the charge quantization, what is meant by the charge integrity, means the integral charge, like the charge is considered is quantized, why it is plus and minus, and all these things we will discuss. So this was all the introduction regarding the four kinds of forces, and then the unification of the physical theories, how the electrodynamics came into being from electricity and magnetism, which were converted into electromagnetism by Faraday, and then Maxwell and Lorentz did their formulation to convert the things into electrodynamics, and later on with their work the optics was also included in this. So the three subjects, electricity, magnetism, and optics, merged together in electrodynamics. So we will proceed now with the charge.